advanced NumPy operation. We looked at NumPy yesterday, but today we're going to look at some of the advanced NumPy operations that exist. So first, we are going to cover broadcasting in NumPy. Now, what is broadcasting? Broadcasting allows NumPy to perform arithmetic operations on arrays of different shapes. Smaller arrays are automatically expanded to match the shape of larger arrays. Some of the rules of broadcasting include dimensions are aligned from the right, and a dimension is compatible if it matches the other array's dimension. One of the dimension is 1. So let's look at some examples for this. So first, I'm going to import NumPy, and then we'll do some array and scalar broadcasting, and then look at array broadcasting in detail. So for this, I'm going to create a new file, or a Python file, save it under my week 2, day 2. I'll call it day2 underscore samples, and start with importing NumPy as np. Next, let's do some, I'll add a comment here, array and scalar broadcasting. How does this work? So first I'll say array equal to np dot array. So I'll create an array from a list 1, 2, and 3. So this is my array. Now I'm going to say print array plus 10. So what it does is it adds 10 to each and every element in here. If you want to see an example, I'm going to say clear ls, and I'm going to say, oh, I said day samples instead of day 2 samples, but that's fine. I'm going to say Python day samples. I have 11, 12, and 13. So 10 was added to every single element. So it's kind of broadcasting the number to each and every element, and it added there. So in a scalar array. So let's look at more on the array broadcasting. So I have a matrix equal to np dot array, and this one I'll create a 2 by 3 matrix, 1, 2, 3, and the next element in here I'll add 4, 5, 6. Straightforward one. So this will create me a matrix 2 by 3, which is 1, 2, 3, and 4, 5, 6. I'll create a vector np dot array, call it 1, 0, 1. Okay, so there you go. That's our vector. Now I am going to say print matrix plus vector. So the output for this will be based on the values that we have here. 1, 0, 1, it will give me 2, 2, 4, and below it will be 5, 5, 7, because it kind of takes this vector and adds it properly to each line of the matrix. Let's look at the output. And we have 2 to 4, because 1 plus 1, 2, 2 plus 0, 2, and then 3 plus 1, 4. That's what we have. Then next line, 4 plus 1, 5, 5 plus 0, 5, and 6 plus 1. So this is how array broadcasting works, where you take a vector here, a single array, and then I am broadcasting it to the entire matrix here. Next that we're going to look at is aggregation functions. Now aggregation functions compute summary statistics for arrays. So it's pretty helpful in AI world. So let's look at some of the common functions that are available in the aggregation functions. So I'm going to go here. I am going to remove everything, create an array, np dot array. I'll create a matrix here. It will be a matrix of, oops, need to fix this, okay. Matrix of 1, 2, and 3, 4, 5, and 6. So I have this matrix here, which is 2 by 3. Next, let's look at some of the functions. First, I want to do the total sum of all elements. So I'm going to call it sum, and I can use np dot sum. This is the function that you can use. This will give you the total sum of all the elements in this matrix up here. I can say print, I can say what is the mean of this particular matrix that we have. You can say np dot mean and pass the array to it. I can also get the max Similar way, max, comma, np dot max, and pass the array to it. Similarly, I'm going to just copy paste this. I can get max, so I can get min. Say min. There you go. Next, I want to get the spread of the data. How is the standard deviation? Standard deviation. For that, I'll just call the function std and pass the array to it. I can, what else can I do? Oops, sorry. Next, I can get sum along the rows. So sum per row. So that I can say sum along rows. For that, I can say np.sum, and then I give the array, and I'll say axis equal to 1. So it will take one single axis, so it will give you per row. Same thing you can do for column, where you can, I'll say columns, np.sum, pass the array, and axis is 0. So one axis is for the row, and for column, axis is equal to 0. So I do this, go back here, clear it out, let's run it, and you'll see sum is 21. If you add this 6 plus 5 plus 4, 3 to 1 is 21. Mean is 3.5, max is 6, minimum is 1, standard deviation is 1.7078, sum along the rows is 6, 15, 6 and 15, 3, 4, 5, 6, and 6 plus 5 plus 4 is 15. Sum along the columns is 1 plus 4 is 5, 7 plus 5, 7, 2 plus 5 is 7, and 3 plus 6 is 9. So that's how you can use the aggregation functions that are available. Next, let's look at Boolean indexing and filtering. Now, what is Boolean indexing? We use Boolean arrays or conditions to filter elements from an array. So let's look at some examples of Boolean indexing. What I'm going to do here is I am going to get rid of everything. I will create an array of a single axis array 1, 2, 3, 4, 5, and 6. So I have this array available. Next, I am going to filter all the even numbers. So to that, I can say evens array mod. I can also use mod operator equal to 0. What this will give me, it will print 2, 4, and 6. So this kind of filters even numbers. Say print evens, comma, evens. So you can check that out. Next is modifying the elements based on a particular condition. So for example, I can say array is greater than 3 equal to 0. So in this case, if the values are greater than 0, it will make sure that it will change that array values into 0. So I'll say modified array is array. Let's output this and check it out. So I have an array, again, let's clear it out. I have an array 1, 2, 3, 4, 5, 6. So to get the evens 2, 4, and 6, I've created this array. So this is more of a filtering option here. And then to modify elements based on a condition, if you see this 1, 2, 3, 0, 0, 0. So if array value is greater than 3 inside an array item, it will change those values into 0. So this is kind of very helpful when you work with data sets and you want to change values, especially when you are creating models or training models. Next, let's look at random number generation and setting seeds. We already did something random number generation in Python. Now let's see how we can do this using Numpy. So first, for random number generation, Numpy provides the np.random module for generating random numbers. Let's look at some of the common functions for it. So go back to this, get rid of everything. And I am going to first generate random numbers. So I am going to create a random array equal to np.random.rand. That's what we use, 3, 3. So this will create a random array for us, and the uniform distribution of 0, 1. So if I print this, you can see how this looks like. I'm going to say random array. I'll move the array to the next line so it's more clear. I'm going to call it random array. Let's go back, clear it out and run this, and you see you have a random array of 3 by 3 which has random numbers with a uniform distribution from 0 to 1. Next, I want to show generate integers instead of the numbers that we've created. So I'm going to call it random integers equal to np dot random dot rand. It's very similar until here, except it's rand int, say 0 comma 10 comma size of 2 by 3. So this one, as it says here, that it will return you an array, a matrix of 2 by 3 with numbers from 0 to 10 which are integers. So if I want to print this, I can print saying random integers slash n, and that is my random, not array, that is my previous one, random integers. Let's go ahead, clear this out. So now we'll have two different, first for the random array, and then next is random integers. If I run it again, if you see, every single time it will give me different numbers and integers, array and integers, based on what it generates. Next thing that I want to talk about is setting random seeds. Now this ensures reproducibility by fixing the random sequence. Before, what happened was every time I run it, I was getting different numbers every single time. So what I can do here is I can say np dot random dot seed. I like my favorite number 42, and then now when I use the random numbers, output will always be same. So if I go back, clear, run it, no matter how many times I run, the values will be same because I've set a particular seed. And this is very helpful in some of the models where we are training the data set and picking a particular data set for training, and we want to make sure that every time we run that training set, it uses the same training set and testing sets for our models. So that this is very important to know about setting the seeds. Now that we have understood more about advanced NumPy, let's get into some hands-on exercises. Our first exercise is broadcasting operations. We've already done this, but the objective here is to perform operations on arrays of different shapes using broadcasting. So first we'll create a 3 by 3 matrix, and then we'll add a 1 by 3 vector to the matrix, and then we'll multiply the matrix by a scalar. So let's get started. Create a new file, save it as day2 underscore exercise 1.py. Now here, let's create a matrix equal to, okay, I need to import numpy as np, and then np dot array. Let's create this array of, as I mentioned, 3 by 3 matrix. So that I can do by first saying 1, 2, and 3, comma, next one I'll say 4, 5, and 6. The next matrix, it's very easy to guess what I'm going to do, 7, 8, 9. Perfect. I'm going to create a vector which is 1 by 3 array, np dot array, and here the vector I'll give it, this time I'll say 1, 0, and -1. Let's bring some negativity in the vector. Now broadcasting addition, we've seen that. I'm going to say result addition equal to matrix plus vector. So this will give me addition. So let's print it out just so we can see the results. Of course, I like to keep it clean, the code. So addition is common result add. Next, I want to broadcast a scalar multiplication. To do that, let's say result underscore multiplication equal to matrix times 2. Print multiplication, and here I'm going to say result mul. Make sure that it's on the next line for both of them, so it's cleaner result. And now our results should be based on addition of these two. So let's look at it. We clear it out, run the code called as python day2 and .ex1. So there you go. That's our addition first, where we took this 1, 2, 3, 1 0 minus 1, so that's why 2 2 2. 4 5 6, 1 0 minus 1, so that's why 5 5 5, and increment same, decrement, and it was 8 8 8 here. Now multiplication for my matrix, which is this array, I multiplied by 2. That's why every single number 2 4 6 8 10 12 14 16 18 is twice what these values were initially. So that's our exercise 1, where we did the broadcasting operations again. Our second exercise is to generate and filter a random data set. We already did this, but again, this is an exercise that you should probably follow along. Here, the objective is to generate a random data set, filter elements based on conditions, and calculate the summary statistics. So we will create a 5 by 5 matrix of random integers between 1 and 50. You probably know how to do that, but again, we'll practice. Filter values greater than 25 and replace them with 0. We saw that, but we'll do that again. And calculate and print the sum, mean, and standard deviation of the modified matrix. Interesting enough? So let's go ahead and start it. I'll clear this out. I am going to create another one, save it as exercise 2. And here, first thing is import numpy as np. Next step is generate the random data set. So I am going to say data set equal to np.random .rand int. As I mentioned, I want a random integers array, and to this I am going to say, and so it's 1 to 50, so I'm going to say 1 comma 51, and then size equal to 5 by 5 matrix. That's what I wanted to create. So this will give me a matrix of 5 by 5 of random integers between 1 and 50. Our next step is to print this so we can look at the differences. Original /n comma data set. So we display the data set out. Next step, as I mentioned, filter the values greater than 25 and replace them by 0. So first, let me add comments here so we know what we are. Generate random data set. Next I mentioned was we will try to do filter values greater than 25 and replace with 0. And finally, we will calculate summary stats, which are, we'll do the sum, mean, and standard deviation. So now to filter part. Data set greater than, data set where values of data set are greater than 25, I want to replace them by 0. As simple as that. We'll print this modified data set /n comma data set. So it replaces the existing data set with the new data set. Now calculating the summary statistics of the new data set that we have. Let's say print sum of everything should be np dot sum of that entire data set. Next I want to, as I mentioned, I want to do mean, and next I want to do the standard deviation. Now mean was mean and standard deviation was std. So I have this. Let's go ahead and print it out and look if it looks any good. You can, I've not set the seed here. You can set the seed so every time the output is same, but I'm going to run it just one. So I'm going to say python day2.ex underscore ex2.py. And here is our original matrix 21 4. It has some numbers which are about 25. So those are, for example, this 40 is set to 0. This 34 is set to 0. So this is the modified data set with values restricting up to 25. The sum of this entire data set is 182. I'm not going to do addition manually. I trust the system. The mean is 7.28 and the standard deviation is 7.78. Pretty good compared as since I were going from 1 to 25 in this particular case, and we have reduced all the higher numbers to 0. So there is much more flexibility towards the lower numbers, and that's why the standard deviation and mean are more inclined to the lesser numbers. If I don't do this here, it will be much more higher. If you look at it, 584 is the sum, mean is 23, and standard deviation is 13 because we have more numbers towards the higher end. So I'll save this. I'm going to go back. Now, let's talk about the next step. So we have some additional practice for you. You can create a 3D random array and compute statistics along specific axis. We did that previously where we specified axis equal to 0 or 1 depending on if you want to do column or row. Then you can write a program to generate a data set of random floats and normalize the values between 0 and 1. We did something like that. Some examples we have so you know where you're headed. And finally, implement conditional replacement to create a binary mask for values above a threshold. We did